Aroma test bed. Demonstration of end-to-end quality of service procedures. This demonstration is aimed at showing the Aroma testbed capabilities in terms of supported end-to-end quality of service mechanisms. In particular, a session establishment encompassing common radio resource management decisions for the radio access network and IP load conditions for the core network is going to be demonstrated. During the session, the final user requests different quality of service levels that force a quality of service renegotiation between the radio and the core network part. The emulated scenario is a 4 by 8 km service area where interactive and streaming users are uniformly distributed. They do not produce a high-level load. Users are assumed to have multi-mode terminals so that they can make use of UMTS terrestrial radio access network, GSM Edge radio access network, and wireless local area network access, depending on their location in the considered service area. The radio access technology selection algorithm can be configured in the advanced graphical management tool for the common radio resource management module. Possible available algorithms are network control cell breathing, fittingness factor, indoor users to Geran, and a default policy where only the network and user preferences are taken into account. In this case, network preferences are configured so that interactive users should be assigned to UTRAN, if possible, rather than to Geran or wireless LAN, while streaming users are preferably serviced through wireless LAN. Moreover, UTRAN radio access network is connected to the operator core network through ingress router 1, whilst wireless LAN and Geran are connected through the ingress router 2. The user and the test is fixed in a concrete position within the scenario. After having set the parameters, the testbed software is started. Once all the software is up, it can be initialized before actual algorithms execution. Upon the testbed software is running, it is possible to see the concrete location for the mobile terminal under test and also for other mobile users within the scenario. One of the exported statistics within the Common Radio Resource Management module allows monitoring the terminal's location and their current connections. Now the user under test is not connected to any of the available base stations. However, the detected pilots for the best stations offer a good coverage. This can be seen in one of the pre-configured statistics panels, which show the pilot levels. In particular, it can be observed that base stations from the three technologies are reachable from the user and the test location. At this point, the user under test is going to activate a session for web browsing with service quality requirements in terms of warranted bit rate. The required service is requested from the graphical user interface that behaves as quality of service client front end. In this case, web browsing is supported over an interactive traffic class and bit rates of 64 kilobits per second for downlink and 32 kilobits per second for uplink have been selected. After having requested this service, the quality of service management entities accept the user with the aforementioned quality and the bearer is activated. At this moment, the multimedia IP-based application can be used because there is end-to-end connectivity through the testbed. Opening a web browser, it is possible to see the pages served in the testbed server personal computer. Now the user under test has a connection through Ultron, as it can be observed by the line connecting the terminal and the base station on the scenario map. Also in the traffic switch statistics panel, the current radio access technology is set to the Ultron identifier, which corresponds to the 0 values shown in the left graph when the session is activated. The right graph shows the current ingress router to which Ultron is attached. Taking advantage of the connectivity, the user may try to download one of the files available at the Aroma web page. For instance, it is possible to select one deliverable file. Upon starting the data exchange, the amount of data transferred through the radio access technology can be monitored by means of the Ultron traffic panel. In the downlink, a constant rate of 64 kilobits per second is achieved after having started the file download. This transfer speed is also observed in the Browser Download Manager window. The file is long and the user has to wait for a long while. To speed up the transfer, the user decides to request more bandwidth. In the Quality of Service Client graphical user interface, the downlink speed is set to 124 kilobits per second and a change to the service is requested. If there are enough resources, the service change will be accepted. After this change, the transfer speed at the radio access technology for the user under test immediately increases. Also, at the web browser download window, a progressive increase in the mean transfer speed is observed. Once having observed the events on the test bed, it is possible to analyze the messages that the different entities exchanged. If the software modules are stopped, the generated logs can be merged and saved to see, step by step, all the messages. For the shown scenario, all the modules of interest can be selected. In the log viewer, every module log will appear in a different color and chronologically ordered. In this case, there are messages to configure to core network and access network elements when any event is detected. The first relevant event is the request of activation of a service from the Quality of Service client. Another relevant event is the request of service modification, and the last one is the deactivation of the service. After having saved the generated logs, the Dynamic Viewer tool can be used to load such logs and replay the messages exchanged between the different entities. In this case, the messages exchanged between the mobile node QoS client, WQB and BB modules are shown.